Welcome to empirical formulas. We have lots of different varieties today. We are going to start off with what's known as determining the empirical formula by analysis, and then we're going to learn about combustion and then about hydrates, and they will probably be 3 separate videos, so look for them. First of all, we need to know what an empirical formula is. So we've gone over it already in class. You can look up definitions, but essentially the empirical formula is the most reduced ratio of atoms, and then the molecular formula represents what the chemical formula really is. All right. So when we're doing empirical formula by analysis, what we're looking at is, usually it's given to you in terms of percentages. And then so if it's in percentages, you can assume that you have 100% or a 100 gram sample, and then that becomes the amount of grams of that element that's present. First thing you do is convert all the masses into moles, and you do this by dividing by the molar mass of each individual element. Then you divide each of them by whichever one comes out with the smallest number of moles. That gives you a proportion of the elements to each other. If any of those elements are, say, you get a ratio that's 1.33, well, you can't have a third of an atom, so you have to make all of those numbers whole numbers. So 1.33 times 2 would still give you a fraction. 1.33 times 3, however, would give you 4, or very, very close to 4. And that would be a number that you could use in your ratio. All right, so let's move on to exercise number 1. And in exercise number 1, we have cumene, which is a hydrocarbon compound of carbon and hydrogen. It's 89.94% carbon. And since the only other element is hydrogen, 100 minus would give you your hydrogen. It also tells us the molar mass right here, and we want to know the empirical and molecular formulas for cumene. So I'm going to start off. I've got carbon and I've got hydrogen. That's what I know to begin with. It tells me that I have 89.94%, and because it's a percentage, I can get that pretty easily. That's how many grams. The hydrogen would be 100 minus 89.94, and we're assuming it's totally 100% so that we don't have to worry about sig figs there. That gives me 10.06 grams of hydrogen. Alrighty, so that's the first step. The next thing we need to do is convert to moles. So to do that, I'm going to divide each of these elements by their molar mass. Carbon is 12.01, hydrogen is 1.01. And again, these are part of a compound, so we know hydrogen's diatomic, but part of a compound, it's by itself. So the moles that I get here, I get 7.49 moles of carbon, and I get 9.96 moles of hydrogen. Alright, so the value that's the smaller of these two, second, divide by smallest. Divide both of these by 7.49. And then I get a ratio of 1 for the carbon to 1.33 for the hydrogen. Oh, lo and behold, that's the one we just sort of did. We can't have a third of an atom, but we just saw a second ago that we could multiply that by 3, which would give me 4. And if I do it to the hydrogen, I have to do it to the carbon also. So now these values give me my empirical formula. 3 C's and 4 H's. So that's my empirical. To get my molecular formula, I have to come up with a ratio because it has to be a multiple of the molecular formula to the empirical formula. So the way I'm going to do that is with molar masses. So I'm going to put the molecular formula's molar mass on the top. I'm going to find the empirical formula's molar mass and put that on the bottom. And they have to be some multiple of each other. So molecular formula was given to us in the problem. That was 120.2 grams per mole. The empirical formula's molar mass, C3, 3 times 12.01 plus 4.04. That gives me 40.07 grams per mole. And you can get pretty close without even having to divide here. 120 divided by 40, reduce that to 12 divided by 4, gives me a ratio of 3. So what that means is that my molecular formula is 3 times what my empirical formula was. So then it's really C9H12. Okay, exercise number 2 is a very similar setup. So all I'm going to do for exercise number 2 is actually give you the answers. The empirical formula ends up as C5H4, and the molecular formula ends up as C10H8. So please try that and see if you can get those values. And if you don't, please come and ask for help or call a friend, etc.